Welcome to this video on permutations versus combinations. So we didn't have a chance to talk about permutations and combinations because we ran out of time this school year. So thank you for watching this, so that way you will be able to answer the questions on the CRT that deal with this concept. So let's first talk about what a combination is. We're going to start out with this one right here. So permutations and combinations both have to deal with the total amount of possibilities that you can have. So let's say that you have a combination pizza. So a combination pizza is something that has a bunch of different toppings on it. But let's say that we have a lame pizza shop and the only options for the toppings in their pizza are pepperoni, and they offer you olives, and they offer you anchovies. Yum yum. So pepperoni, olives, and anchovies. So those are your three options for the toppings of the pizza. And let's say that you want to pick a pizza that has two toppings. So let's list all of the possibilities that you can have. So if you were to have a pizza, you can get a pizza that has olives and anchovies. You could get a pizza that has pepperoni and anchovies. Let's just a little more systematically, actually. Let's erase that. Let's start out with pepperoni being our first option, and then what's the other possibilities? So if you pick pepperoni first, you got pepperoni and olives. If you pick pepperoni a second time, you can pick anchovies, right? So that's our first option for the pizza and our second option. And then what about our third? Let's see. So what if we did olives first and then anchovies? So are there any other possibilities? Do I have a fourth option? Maybe anchovies and olives? But that's the same as pizza 4, right? Pizza 3 and pizza 4 are exactly the same. Olives anchovies is the same thing as anchovies olives. Because the pizza guy, even though you tell him a certain order in which you want them on it, that doesn't mean that he is going to necessarily put them on that order. So we only have three options. We only have the PO, the PA, and the OA. So now let's look at the options for a lock. So let's say that you had a lock. And you may have heard that they are called combination locks, but this is a lie. Combination locks is a lie because it's a permutation lock. Combination is not as specific as we need it to be. So for a permutation lock, let's say there are only two possible things to turn around, and let's say it only has three possible choices for it. So let's see. So we have, you could pick 1 to be the first one, correct? And then 1 the second one. You do 1 the first, 2 the second, 1 the first, and 3 the second, right? Those are all legitimate options. Or you could pick, so that's 1, 2, 3. Or you could pick 2 to be first, and then you could pick, let me erase that. 2 to be first, and then 1 to be second, 2 to be first, 2 to be second, 2 first, 3 second. So that gives us 4, 5, 6 options. Or you could pick 3 to be first, then 1, then 3 and 2, and then 3 and 3. That would give us 7, 8, 9. 9 options. So we have 9 possibilities here, which is pretty incredible because you consider both of these situations between this permutation lock and this combination pizza, that both of them, we only picked 2 things each time, and we only had 3 options, but one only had 3, and one of them had 9. So take a second and think about what's different about a permutation and a combination that would lead to you having only 3 for a combination, 3 possibilities, but 9 for a permutation. Go ahead and pause it and think about that for a sec. Okay, hopefully you noticed something, that for a pizza, it doesn't matter what order you have. you put the ingredients on. So if you do pepperoni and olives, it's the same thing as olives, pepperonis. However, up here, if you look at option number 2, which was choosing 1 and then 2, that is not the same thing as choosing 2 and 1, right? So there's a big difference there. One will give you access to a lock and one will not. So we say that for combinations. We say order, so the order that we pick them in, olives, pepperonis, or pepperonis and olives, order doesn't matter. It doesn't matter what order you pick them, what comes first and what comes second. Order doesn't matter. So let's highlight that. That's important. Order does not matter. And for permutations, you can probably guess it before I write it, that order does matter. Does matter. The reason why that's so important is because that's order mattering is what gives us a lot more possibilities in the permutations as opposed to the combinations. So let's go through and do a couple problems from the exam, the practice test, to reinforce this concept. So on number 80, it says follow which of the following situations is an example of a permutation. And I put our permutation lock, right? It's no longer a combination lock, it's a permutation lock, because order does matter. It matters what order we pick the numbers in. So let's see which of these would have the order mattering. So the first one says the number of ways a committee of 4 can be formed from a group of 10 people. So on this one, so let's say we had person 1, 2, 3, and 4. They have exciting names. So the order does matter on these ones for the permutation. Sorry, I got confused. I got distracted for a second. So we're talking about the number of ways a committee can be formed. So we have persons 1, 2, 3, and 4 chosen for our committee. Those are very exciting names, 1, 2, 3, and 4. But does it matter if I pick person 4 first, and then 1, and then 2, and 3? No, it's the same committee. I mean, maybe person 4 feels a little better that he was picked first for the committee, but I mean, they're all still on the committee. So this would be a situation in which the order does not matter. And we're looking for when order does matter. So that one is gone. So being part of a committee, that one would not matter. So let's look at the next one. The number of ways a president, vice president, and treasurer can be chosen from the group of 15 people. So we have president, vice president, and treasurer can be chosen from a group of 15 people. So let's say that person 1 was chosen to be president, person 2 for vice president, I don't know why I did a B, vice president, and person 3 chosen for treasurer. Is it a different setup if I put person 3 for president, person 1 for vice president, and person 2 for treasurer? Yeah, that's a different, completely different presidency, because number 1's no longer president. Whereas before they were just committee members, this is actually a situation in which order does matter. So I'm going to circle that one, and then we'll come back to it we'll read the rest of them just to make sure that that is the only one which order matters. Okay, so let's go on to the next one. The number of three topping pizzas that can be made from 20 ingredients. Well, we've already talked about pizzas and how those are combinations, so I already know I can cross that one out. Because it doesn't matter if you choose anchovies, olives, and pickles. If you switch the order of that, it doesn't matter at all. And the last one, the number of 5 card hands that can be dealt from a 52 card deck. So if you're dealt 5 cards, so let's say you're dealt a 1, 2, we'll skip 3 just for fun, 5 and 6 in that order. Does it matter if you get 2 before 1 and then 4, 5, 6? No, it's the same hand. So the order does not matter on that one. So B would be the correct answer. Okay, so now we're going to move on to the next problem. Problem 79. So which of the following situations is an example of a combination? So remember, a combination is our pizza. Combination pizza is in which the order in which we put the toppings on it does not matter. So, the number of 5-digit zip codes that can be made from the numbers 0 through 9. So a 5-digit zip code. So let's say we had a very boring zip code that was 11211. So that was my zip code. So if I were to switch two of these numbers around, 11121, is that a different zip code? Yes. So therefore the order does matter. So that one is not correct, because our order matters. So the number of ways there are to arrange the order of a five-person bowling team bowls in. Okay, so let's talk about our 5-person bowling team. So let's say that we have person 1, 2, 3, 4, 5. Those are their names. Don't make fun of them. 1, 2, 3, 4, and 5 are on a bowling team. And let's say that we switch up 2 and 1, 3, 4, 5. Is that a different order? Yeah. Like, I don't know anything about bowling, but it seems like it makes sense that it would matter who went first and who went second and who's the guy who's bringing up the rear. You want your best player probably last. So the order on this one would matter. So next one, C. The number of ways you can choose 3 novels from a summer reading list of 10. So the number of ways you can choose 3 novels from a summer reading list. This one, I don't like how it's worded. So the number of ways you can choose 3 novels from a summer reading list of 10. So we have our 10 options. So let's say we have book 1, 2, and 3. So let's say you have books 1, 2, and 3. And then we didn't choose 4, 5, 6, 7, 8, 9, or 10. So if I picked books 1, 2, and 3 to be my summer reading list ones, and if I picked 2, 1, 3, does the order in which I picked them matter? I can see a debate for this. I could see you saying, well, the order would matter because maybe they wouldn't be able to read the last book in time, so you'd want to read the first one first and go down from there. Meaning, put the first one, the most important book, for them to read first. So if you were to say that, maybe the order would matter. But I think the key thing here is that this is a summer reading list of 10 novels, and you're not saying that they have to read them in this order. So because of that, you're not dictating the way or the order in which they read them. You're just saying, here are 3 options to read. And so if you give someone 1, 2, 3 as options, or someone as 2, 1, 3, it's the same thing. So the order does not matter on this one. So C is going to be our answer. Let's just check the last one just to double check, because that was kind of iffy. So the number of ways gold, silver, and bronze medals may be awarded to 150 runners in the race. Anytime we have like positions, like what we had before, vice president, president, and treasurer, those are always going to have the order mattering. Because, I mean, if guy 1 gets the gold and guy 2 gets the silver and guy 3 gets the bronze, I mean, if you were to switch them arbitrarily, so guy 1, guess what? Even though you won, you did not get the gold. We're going to give it to guy 2. I mean, guy 1's going to be pretty ticked about that, because the order does matter in this situation. Okay, hopefully that helps, that you understand the concepts well, and catch you in the next one. Oh, let's see, the code, the special code on this one that I need you to write down is P, as in Peter, so PVC, PVC, like the pipe. All right, see you when I see you.